Hello and welcome to IT Chronicles. My name is Casanova. We're here at the Gartner Data Center Conference in Las Vegas. And we're here with my co-host, Charlie Betz.
Carlos.
And Brian Biles from Datrium.
Hey.
Welcome. I guess you guys got a lot of exciting news kind of going on lately, some new funding, a lot of great product advancement. Tell us a little bit about that.
Yeah, thanks. We just came to the show with a new funding round. We raised $55 million Series C.
Wow, that's great.
Wow. So we've only been selling for a little more than 9 months, so that's a big deal.
That is very big.
Datrium's a really innovative, different kind of product. We're trying to take the best elements of convergence and Mode 2 architectures with the best kind of sort of simplicity and ease of management from Mode 1 architectures. Using server resources to get speed in storage, but an off-host box for storing the durable capacity. So we separate the performance and the capacity, and you can scale them independently.
Wow.
Mm-hmm. And as we were talking, it is bring your own capacity, but you're providing a critical management layer.
Yeah, it's actually kind of not that.
No?
You do bring your own something.
Okay.
We sell a box with capacity,
okay.
and it has all the software in it. You bring your own flash on every server for speed.
Okay.
And we upload software to ESX. It does all the stuff a normal array controller would do, but in each host.
Okay, got it.
So each host brings compute resources to the task, and it uses local flash to keep reads off of the network.
Got it.
And keep them local. So it's super fast. It's as high latency, as fast latency as you can get because it never gets on the network. For reads, writes go to mirrored NVRAM in the backend box, so it's as fast as an all-flash array at that level.
Okay.
So by about the fifth, sixth, eighth host, the collection of stuff is faster than an all-flash array. But because you bring your own flash and it uses server CPU, we don't charge for that. We just sell the capacity and upload up to 32 hosts, and we don't charge per host. So the collection of stuff is cheaper than like half the price of a hybrid array.
Got it.
So are you going into mainly, it doesn't sound like a small startup kind of model, or are you going pretty much
It's a
across the board?
startup.
No, not your organization, but your clients,
customers.
your customers and stuff. Are you going into smaller companies or like enterprise class or pretty much
It's enterprise
everywhere?
class, but we're early in our journey. So our first product is about a 100 terabyte box of capacity.
Okay.
That's currently not scalable. It will be next year. And up to 32 hosts in that data store.
Okay.
It's VM Ware only today. It'll be other things later. It's US and Japan today. It'll be other geographies over the next year or two.
Wow.
Okay. Well, I mean, talk to me as if I'm the SVP of I&O for, say, a major bank. I mean, what's the value proposition? I mean, I've got a Hitachi EMC, and I've got people sticking stuff up on Amazon now. I mean, where do you guys play, and why, how's this going to help my bottom line?
The array market is pretty much a dying market because it's very rigid.
Okay.
If you want to have dynamism in how you allocate performance, if you want it to be sort of like Mode 2, you want performance to grow with each server, and you can't get that from an array.
Right.
So you're constantly battling the SAN and the configuration of storage to get to the place you want.
Those are pretty big stair steps, each one of those arrays.
Very
that
big
you buy.
stair steps,
Yeah,
and
okay.
and every upgrade is very expensive.
Yes.
By doing it our way, you take advantage of a little bit of extra server CPU, but everybody has that, and you break all those barriers. It becomes very elastic at a performance level, and can get extremely fast because it's so low latency.
Okay.
We sometimes get compared to hyper-converged products, which have a sort of silo of everything in every server,
Right. Yep.
and then they replicate to each other. The replication causes a lot of neighbor noise, and that makes it hard to get the sort of definite performance that you want in like a database.
Right.
In our case, databases are the highest application attach we have because the hosts don't talk to each other.
Right.
The host talks to its local flash, or it sends a replica to a single pre-configured destination.
And you can horizontally scale.
And we can horizontally scale.
Indefinitely? Or you
No,
said
up to
100
32 hosts.
Yeah, right. No, you made that clear. My bad.
Yeah, more over time.
Yeah, more over time.
So do you see any particular verticals that are leveraging this, or also kind of like size?
It's principally kind of people who are okay with this size of configuration and are using VMware. VMware is currently where we go. We'll be doing other platforms later.
Right. So you really are tied to ESX on this.
Yeah,
right?
but because it's so sort of database friendly or any kind of high performance application, it's very enterprise ready. It has all the HA characteristics that those people expect. Another counterexample, in hyperconverged, because everything's together, if a server has to be brought down for a firmware update or something, that weakens the data availability of that cluster.
Yes.
In our case, servers are stateless.
Right.
If any number of them go down, it doesn't affect the data resilience. That's much more enterprise style. If people are familiar with on-prem equipment that way, we're a better fit.
Okay. I would imagine, I'm starting to now think in terms of a widely known architectural principle that they talk about in mode 2, the CAP theorem, the consistency availability. Are you really architected for consistency across the board, or is this something that's tunable in your array?
It's not we don't distribute the data availability.
Okay.
It's centralized to a separate layer.
Okay.
So it doesn't have the same kind of problems.
Okay.
Think of it as a super giant cache on every host, writing to a place that has its own HA.
Okay. Okay. Got it. Interesting.
So, I mean, do you really have many? Because, we've been speaking to a lot of folks on the hyperconverged, like you mentioned. Really haven't spoken to anyone that's kind of in the space. Is there much competition, or is it just you guys?
There are other people that are following this architecture into other markets, but we're the only one that's doing it for sort of general purpose VM Ware style compute.
Wow.
There are other people in HPC that are doing it. There's one guy doing it in sort of data lakes, Hadoop style. It's new. I mean, the principles that we use are very much like AWS, where there are instances with their own local ephemeral storage and S3 for persistence.
Yep,
We're following that model, and that model is fairly new. Everybody else is taking kind of off-the-shelf file system notions and just trying to package them together.
Right. No, but statelessness is where the app market is going. I mean, clearly with Docker and everything we're seeing there.
Right.
Yeah. So you're positioning yourself to be ready for that.
Right. It couldn't have happened unless there was enough CPU to make virtualization worthwhile. Virtualization had to be there, and Flash had to be both commodity and mature. 5 years ago, it wasn't. So if you tried to just stick anonymous SSDs, your server vendors' SSDs in and depend on them, it wasn't always possible. Now they're very stable. So this kind of approach makes a lot more sense.
Well, that sounds great. I mean, I'm really curious to see how that plays out over over the years, because it sounds like amazing opportunity for a lot of organizations there for yourself. So thanks for coming on. We'll look forward to bringing you on in a year or so. See how maybe we'll be back here again and see how things are going with your progress.
Appreciate it. Thanks for the time.
Thank you for the time. Thanks, Ollie.